Good morning, everyone. Welcome to Guru Brahma classes for JEE and NEET. Today's topic is radial probability distribution curves. Is that radial probability distribution curves? See here, what are those radial probability distribution curves? Generally, when curve obtained by plotting probability function, which is also called as P or D, 4 pi r square psi square and radial distance. So let us see that. So now we are plotting a graph 4 pi r square psi square. What is that called as a radial probability or radial probability function? This is called as a radial probability. Radial probability or probability, radial probability function, and radial distance. So this is r. That means distance from the nucleus, radial distance, are called as what? Radial probability distribution curves. Okay, radial probability distribution curves. So let us see some curves. Then we shall come to this theoretical concept. See here, there are some curves. When a graph is drawn between, for 1s orbital, when a graph is drawn between psi taken on y-axis and radial distance taken on x-axis, then what graph is obtained? So this 0, this is nucleus. Very closer to the nucleus, there is psi. Are you finding this? Very closer to the nucleus, there is psi. Already we have studied that psi represents an atomic orbital. Atomic orbital. Atomic orbital means you can say that it is the region around the nucleus where there is probability of finding electron. So electron here, probability of finding electron is more very near to the nucleus, not in the nucleus, but very near to the nucleus. And when the distance is increasing from the nucleus, the probability is decreasing. The probability is decreasing, right? So that is the graph obtained when drawn between psi and radial distance from the nucleus. But when coming to psi square, we know that psi can have both positive and negative. This already we have studied. This is psi. Psi can have both positive as well as a negative. Psi means wave function or amplitude also. So, but when a graph is drawn between psi square will always be positive. Actually, psi square, what is this psi square? It represents probability density. What is that? Probability density. So this actually represents the probability of finding electron at a particular region around the nucleus. So to make psi positive, we are using psi square. That psi square is describes about actual probability of finding electron, and that is mentioned as probability density. So probability density, again, when you draw a graph, the same we get very closer to the nucleus, the probability is more, and as the distance increases, the probability decreases. Right? When you see this for 2 years, let us look it for 2s orbital. So very closer to the nucleus, no doubt about it, there is more probability of finding electron. But as the distance is increasing from the nucleus, the probability decreases. And at a particular distance from the nucleus, the probability is zero. Okay, probability is zero, psi is zero. And as psi can have negative value, you are also finding negative. You see, it is also negative. Negative you are finding. Right? So if you see 2s orbital, for example, see this is the 2s orbital. 1s orbital size coming to 1s orbital, when compared with the size of 1s orbital, 2s orbital size will be larger. And there are two areas where there is maximum probability of finding electron. Between these two areas, there is a region, spherical region, where there is no probability of finding electron. That's called as what? Spherical node. So, what is the spherical node? The spherical surface where there is no probability of finding electron. No probability of electron. That is called as node. See here, when this graph is intersecting at on x-axis, this is x-axis, that point is called as what? Node. What is this called as a node? So number of spherical nodes is given by the formula n minus L minus 1. Here for 2s orbital, 2 minus, what is the L value for s orbital? 0. 0 minus 1, that is equal to 1. So there is one node. But if the graph is drawn between psi square and r, anyway psi square means there will be no negative. So only the graph will be in the positive region. You are finding very closer to the nucleus, it is having more probability, and as the distance is increasing, probability is decreasing, and at a particular time and at a particular distance from the nucleus, what is that? The probability is 0. And this graph, where it is at the point where it is intersecting on x-axis, and that is called as what? Node, which is also called as a spherical node. Right? So how many peaks it is having? Right? 1. Right? So now let us see here for 3 years. Let us discuss the same for 3 years. See 3 years orbital. This is which orbital? 3s. So number of spherical nodes is given by n minus L minus 1. So for 3s orbital, 3 minus L value for s orbital 0 minus 1, that is equal to 2. See, you are finding 2 nodes. Here is one node, here is one node, 2 nodes. But when you are drawing the graph between psi square and r for the 3s orbital, the same 3s orbital, see how many nodes you are finding? 2 nodes and 3 curves, 3 peaks. And always you have to remember that when there are more than one, Always we need to remember that when there are more than one peak, the graph will be like this. 1, 2, and 3. Always it will be descending order. It will be descending order. So how many nodes are there? 2 nodes are there. So 3s. How to identify this? Whenever graph is drawn for s orbital between psi and r or psi square and r, always it starts from non-zero. This point you need to remember. It starts from non-zero. And if there are more than one peak, the peaks are the peak of the curve will be in the descending order. The peaks of the curve will be in descending order. More, less, very much less. So how to identify this? See, there are 3 peaks, 1, 2, 3, simply representing that this is 1s, this is 2s, this is 3s. So in that way you can remember also. We can remember, right? So when you are drawing graph between psi square and r, the graph does not move into negative because psi square will be always positive. Psi square will be always positive. See, let us see this. Now we are speaking about the graph drawn between 4 pi r square, psi square and r. So what is actually this called as radial probability distribution curve? What is the actually it is called as a radial probability distribution curve. Radial probability distribution curve. So first point, what did we discuss? We have discussed that for s orbitals, especially s orbitals, when you are drawing graph between psi and r or psi square and r, always the graph starts with non-zero. S orbital, for s orbitals. When you are drawing graph for 1s orbital between 4 pi r square, psi square and r, it starts with 0, and as the distance increases, the graph increases and reaches a peak value, and still if distance increases, the graph decreases. And what is this peak called as a antinode? What is that called as a antinode? At what distance there is maximum peak? At what distance from the nucleus there will be maximum maximum peak of this curve? At what distance? 0.529 angstrom units. This already we have studied. Radius in the terms of radius of nth orbit. Radius of nth orbit is equal to 0.529 angstrom units into n square by z, and 0.529 angstrom units is called as Bohr's radius. Bohr's radius, right? So for 1s orbital at this 0.529 angstrom units, there is a antinode that the curve is at its maximum peak. Okay. So whatever the orbital you write or you draw the graph between 4 pi r square, psi square and r, it always starts with 0. You have to remember that it always starts with 0. So let us take for 2s orbital, there are 2 peaks. How many peaks? 2 peaks. One represents 1s and another represents 2s, like that. Okay, there are 2 peaks. The first peak is at a distance of 0.529 angstrom units, and the next peak is at a distance of 2.6 angstrom units. Okay, 2.6 angstrom units. Already I mentioned that when a graph is drawn, whatever the orbital it is, it always starts with 0. And if there are more than one peaks, the peaks of the curve will be in ascending order. Which order? Ascending order. Before we have spoken that when a graph is drawn between psi square and r, then that will be in descending order. But when a graph is drawn between 4 pi r square and psi square and r, it will be in ascending order. This one you need to remember. Ascending order. So in the same way, if you see 3s orbital, see 3s orbital 4 pi r square, this is for 3s orbital. When you are drawing graph between radial probability and r, how many graphs did we get? How many curves did we get? How many peaks did we get? 3 peaks. And these 3 peaks are in ascending or descending? They are in ascending. That you need to remember. So 1s, this can be, how can we remember it? 1s, 2s and 3s in this way. Right? Like that. So this is for 3s. Next, coming to, let us see about 2p orbital. So this is 2p orbital. So when you are drawing graph between psi and r or psi square and r, p orbital, for p orbital it always starts with 0. But s orbital it will start with a non-zero. For p orbitals it always starts with a 0. Starts with a 0. So psi and r, you will get a graph like this with one peak, and psi square and r will get the peak will be somewhat more. Okay, but 4 pi r square psi square also we get the same one peak. Whatever the orbital it is, when you are drawing graph between radial probability and r, it always starts with a 0. Okay, now let us see here. A graph is given like this. A graph is given like this. So 1, 2, there are 3 peaks. So this will be possible only for 4 pi r square psi square. Question is given. This is a question. R. For which orbital this graph is applicable? 3s, b, 4p, c, 5d, e, a, b, c, d. C. Let us see. D, 4f. So the question is more than one correct option question. So what will be the answer? First thing is, when you are drawing graph between radial probability and r, first thing you need to remember this, the peaks will be in ascending order. Peaks will be in ascending order. Okay, they are in ascending order. And it can be applied to any orbital based on the number of peaks. Yes, if you look for 3s, this is for 1s, 2s, 3s. Yes, it is applicable for this. Next to 4p. So P starts from 2p. So 2p, 3p, 4p. Yes, it is also applicable for this. That means when a graph is drawn between for 4p between the radial probability and R, we get this same graph, this graph. 5D, let us see. This is 3D. It starts from 3D, 4D, 5D. So for 5D also we get the similar graph. Do we get it for 4F? F starts from 4F. So you cannot have that. So for 4F, 4 pi r square psi square r, you will get only one peak because 4F. F starts from 4th orbit. So in that way, the question can be asked. So the main thing you need to remember is the peaks must be in ascending order. When a graph is drawn between radial probability and R, and the peaks must be in descending order when a graph is drawn between psi square and R. That one we need to remember, right? Let us see the theoretical concept regarding this. Now we have gone through the graphs. So number of peaks obtained in a curve is given by n minus L. Okay. For example, 3s. When a graph is drawn between drawn for 3s, how many peaks are there? 1, 2, 3. Okay. 1, 2, 3. This is for 3s, 4 pi r square psi square and r. So 3s, 3 minus L value how much? 0. That is equal to 3. So 3 are there, 3 peaks. That way, number of peaks obtained in the curve by using the formula you can see. Next, the nodal surface or spherical node for 2s orbital exists at a distance of 2a0 from the nucleus, where a0 is the Bohr's radius. The curve for 2s, already we have drawn the curve for 2s, has two peaks, passes through lower maximum. Before we have seen that, okay, for 2s orbital, 4 pi r square psi square and r, we get two curves. Okay, one is at a distance of 0.529 angstrom units, another is at a distance of what is that? 2.6 angstrom units, radial distance. The space around the nucleus where there is probability of finding electron, that probability of finding electron is discussed in the terms of psi square is maximum, and that is called as what? Orbital. The maximum probability of finding electron in an orbital is how much? 90%. So these graphs already we have gone through. Okay, these two graphs already we have gone through. So it may be noted that in the graph B, if you look into, this is graph B, for 1s orbital, the probability density is maximum at the nucleus, close to the nucleus, and it decreases sharply as we move away from it. It is decreasing sharply. For 2s orbital, the probability density first decreases sharply. It is also very closer to the nucleus. Its probability is also more, but as we move away from the nucleus, it also decreases sharply to 0. So where it touches the x-axis, and that is a 0 probability, and which is called as what? A node. and again it starts increasing. See, again it starts increasing, right? The region where probability density psi square is 0 called as what? Nodal surface or spherical node. So that is with our radial probability distribution curves. Thanks for watching up to the end. We shall meet in the next video discussing other topic.